Hello students, in this video we will be studying about properties of matter. So, before starting the chapter we will have to understand few terms and we will start with understanding the terms and we will proceed to the chapter. First of all, we know when we are talking about matter, so we have three states of matter. It is solid, liquid and gas. But in this chapter we will be discussing about solid only. We know the solids are rigid, which have fixed volume, fixed mass and all. So let us consider these are the molecules in solid and in equilibrium state. Equilibrium state means when no external force is being applied on the body, then the force of attraction due to which the molecules are stable. Stable means they are not changing their position with respect to the other molecule. That force between the molecules is known as intermolecular forces. Intermolecular forces. And these intermolecular forces are responsible for the stability of the molecules in the solid. Suppose we apply any force on any of the molecule. Let us consider we have applied F amount of force in this molecule, due to which the molecule displaces from its original position and gets into its new position. This force which we are applying externally is known as applied force. Okay? It is applied force. And this applied force is changing the form of the state of the matter, that is solids. Original configuration is being changed because of this applied force. That is why this force is also known as deforming force. Deforming force. Now, when the force is released, when the deforming force is released, two things can happen. 1 and 2. Let us consider the first thing that can happen is this molecule which has been displaced from its original position will stay in its new position. Stay in its new position. New position. And the second case can happen that the molecule will move. Okay? The molecule will move to its original position. Original position. Now, if the molecule stays in its new position after removing the deforming force, then the property of the matter is known as plastic. For example, you might have seen duff. मम्मी जो आटा गूंजती हैं, that duff, when you press it, ठीक है? When you press it, the shape of the duff changes, and that when you remove the force, the shape of the duff does not come to its original shape where it was before applying the force. And duff, and we can also consider clay. These are the easy examples that we are studying here. Now, if the molecule after removing the deforming force moves to its original position, then that property of the matter will be considered as elastic property. Elastic property. For example, you might have seen rubber bands. Okay? Rubber bands. After applying the force, the shape of the rubber band changes, and after removing it, the rubber band comes to its original position. So, we will be studying, in this chapter, we will be studying here elastic property of the matter. What happens when the deforming force is applied? This elastic property, due to this elastic property, what happens? The molecules which was displaced gets another force of attraction within the body. This force of attraction within the body, due to which the molecule will come to its original position, is known as restoring force. Restoring force, and this restoring force acts within the body. Okay? Now, due to this restoring force, this molecule which was displaced comes to its original position. So when the force was applied, the molecule changed its position. The molecule changed its position means the matter, that is the solid, is deforming, and as a result of the applied force, what we get is deformation. Deformation in the solid, and this deformation is nothing other than strain, that we will be discussing again later on. Strain, and due to this strain, when we remove the applied force, the restoring force develops and it pulls the molecule back to its original position, and this force is known as restoring force. And what is a restoring force? It is nothing other than the restoration of the change in shape or configuration of the molecules. Configuration of molecules, it is clear. So this is what happens in the elastic property. First, when we apply the force, that is the deforming force, due to that deforming force, the shape of the matter changes, and when we remove it, there is a force which is developed inside the body, and that force brings the molecule in its original position, and that force which is acting within the body is known as restoring force. Clear? Here we have studied one thing, that is strain, and along with that we will also study stress, and with that we will study strain as well. Strain is nothing other than the change in the shape or the configuration of the body, and stress is nothing other than restoring force applied per unit area. Per unit area means, for example, we are talking about, let us consider we talk about a cylindrical rod. When we apply any force on this to change the shape of the rod, the force on it, due to this applied force, there will be a restoring force act within the body, and this restoring force is acting, let us consider, in surface area AR. Therefore, the stress in this will be equal to restoring force upon area of this in which the force has been applied. And and what is strain? It is nothing other than the ratio. It is the ratio of deformed configuration, deformed configuration upon the original configuration. Original configuration. This deformed configuration can be in the length, it can be tangential, it can be volumetric. So we will be discussing now about the types of stress and types of strain. So now we will discuss about the types of stress and the types of strain. Simultaneously, we will discuss both the things. The first thing about the stress, the first part is tensile stress. Along with tensile stress, we will study longitudinal strain. Longitudinal strain. Tensile, or it is also considered as compressive if we are compressing the length of any material. Let us consider we have a rod whose length is capital L, and this area of cross section, let us consider this is A. When we apply the force, when we apply external force, what happens? The configuration of this rod changes. Changes means the length. Let us consider the length is increased by delta L. This, when we talk about increasing the length, we talk about tensile stress. When we apply the force to compress it, that will be considered as compressive stress. Now stress, the formula of stress we have studied, due to the stress is equals to restoring force per unit area. Restoring force per unit area. In this, due to this applied force, there will be a restoring force acting inside the body will be equal to restoring force upon the area of cross section. We have considered it as A. This is tensile stress or compressive stress. Now when we talk about longitudinal strain, the strain for longitudinal strain will be equal to, this is the ratio of change or deformation upon the original shape or the original configuration. The deformation is delta L, that is delta L upon the original length, that is capital L. So this is longitudinal strain. Now when we talk about shearing stress, and along with that we will be studying shearing strain. Shearing, the force, when we talk about shearing stress, the force acts tangentially. Here the force is acting perpendicular to the surface area. Here the force will act tangential to the surface area. Let us consider we have a sponge like this, and this is the surface area. Okay? This is the surface area. Let us consider the surface area is A. When we apply the force in this direction along the surface, in this direction, the surface area and the force are tangential to each other. This is force applied. So here stress will be force applied upon area, which is the formula of the stress, and the strain will be like this. This was the original configuration. When we have applied the force, it tangentially it became something like this. Okay? It became something like this, and this is due to the stress. Okay? Due to the force applied. And let us consider the deformation is angle theta. We denote shearing strain with theta, and let us consider this length which has been removed. Let us consider this is delta x, and the length of the material, let us consider it is h. Okay? So this is h and x. So shearing strain will be equal to, we know the formula, that is arc upon radius. Arc means delta x upon radius, that is h. So this is shearing strain. Now the third part is volumetric strain and volumetric stress. Volumetric stress and volumetric strain. So here, when let us consider we are throwing a ball. Let us consider this is a football. This we are throwing inside an ocean. What happens? Along with the depth, by the time it goes inside the ocean, the number of forces acting on it increases, and the force is acting along all the directions on the football. Okay? And due to this force, what will happen? The force is acting in all the parts, and this sum of all the forces divided by the area of the football will be equal to volumetric stress. That is the formula that we have studied about stress. In volume, what will happen? Due to the force acting along all the directions, the shape will reduce to a smaller size. Due to this reduction, the volume is reduced to delta V. The original volume was V, and due to the reduction the volume became delta. The change, ठीक है, the change in the volume becomes delta V. So here the strain will be equal to, volumetric strain will be equal to change in volume upon the original volume. Clear? So this is, in this video we have studied three things. One is the elastic property. Along with that we have studied the plastic property as well. And here we have studied two new terms. One is stress and the other thing is rest. Rest of the part we will be studying later on in the other videos. Thank you very much for watching.